Welcome, and in this lesson, we're going to talk about Amazon Web Services, IAM Identity and Access Management. So what is IAM? IAM provides access and access permission to our AWS resources. It allows us to create users globally that apply to all of our AWS regions. With this, we can create access policies that grant users specific access to specific AWS resources within specific regions or even specific availability zones. So that's what policies do. They allow for granular API level permissions for granting users and groups access to specific AWS resources. So what are the few key benefits of IAM? Well, we have central control of all our AWS resources. We can manage access to and from our users through IAM. We can create consolidated billing for our AWS users rather than having multiple AWS accounts, which is what used to be the way of doing things before IAM came around. This way, we can actually grant access to developers. So if developers need specific access to only development servers, we have resource level permissions that say developers can only have access to this set of resources or these EC2 instances. We can ensure that users are accessing the account, AWS account, from specific networks. We can say that this CIDR range is allowed to log in to our AWS console or make API requests to Amazon Web Services. So we can provide really granular level control access to our AWS Web Services. It allows us to easily manage our security credentials for our users and groups. We can manage the API access keys, for example. We can provide temporary access when needed. For example, a little bit about simple token service. Or we can use federated accounts with Active Directory and SAML in order to create temporary credentials for Active Directory users. Instead of having to create an IAM user, we can actually integrate Microsoft Active Directory with the SAML connector and a simple Active Directory connector so that we can grant temporary permissions to users that are going to log into the AWS console. But we don't have to create a new AWS username. Instead, we can just create a role that the Active Directory can assume for the user to have access to. Now that's a pretty advanced concept. We'll talk a little bit about it. It's kind of outside the scope. We do need to know a little bit about it. We're not going to have to know how to apply it. So we'll keep talking about this as we move forward and it'll become a little bit more clear for you. So again, we can federate with SAML providers such as Active Directory for temporary and single sign-on access. And we can provide roles that either EC2 instances can assume or even other AWS accounts. So for example, my AWS account can assume a role with specific permissions in your AWS account. And we'll have a pretty simple setup on this to demonstrate how this works. Roles even allow our EC2 instances to assume specific privileges and to be able to communicate with the API based off those policies assigned to a role. So again, we can manage users and groups, API access, password policy, multi-factor authentication on a per user basis. It provides pre-built policy templates to assign to our users and groups. So for example, we can give a user or a group administrative access, which means they have all access, unlimited access to all AWS resources, including user and group management. Power user access does not allow for user and group management, but allows administrative access to all other services other than IAM. Or let's say our accounting department has a requirement to be able to log in and view AWS bills and resources. We can grant read-only access. But it goes a lot more granular than this. We could grant read-only access to just a specific AWS service. So we'll demonstrate this as well. So users and groups. Groups assign permission policies to more than one user at a time. So we could have a group called developer. We could have 5 of our users be developers and they have the same permissions. We can apply those permissions to one group rather than having to manage each user's permissions individually. So the best practice when working with IAM is to not use our root user account. The root user account is considered the email address you used when you sign up to Amazon Web Services. Instead, best practice is for you to create an administrative user for yourself enable multi-factor authentication for your root user, and also multi-factor authentication for your regular user login. User API credentials, API keys, please note this is very important. API keys should never be stored or passed to an EC2 instance. Instead, we should try to use IAM roles. So users can have group and regular policies apply to them. A few things about this is that by default, an explicit deny and an IAM policy always overrides an allow. And by default, unless an allow is specified, all users are denied access to the AWS services. So what are roles? Roles are a way for an EC2 instance or another AWS account to assume certain permissions. For example, when we create federated single sign-ons with Active Directory, you're creating a role, a temporary role for the user to access, and it has specific permissions for that user to assume and execute against Amazon Web Services. So it's really cool, and it's probably one of the best security advantages we have with IAM. So our focus will always be to try to use roles when the situation calls for it, much like if you're needing to execute against the API using command line interface on an EC2 instance, assign yourself a role. So we went through some of the key components that we're going to start talking about. Next, after this lesson, we're actually going to dive in hands-on inside of the AWS console and start setting some of these things up and testing them. So go ahead and complete this lesson and move on.